Good evening. I'm Josh, and today I will be talking about my challenge project. The topic of challenge my prime project is naive Bayes versus logistic regression. So in this project, I would just the main topic of it would be examining the performance of naive Bayes model and logistic regression model under different circumstances and input of data. So this will just be like a short summarized video, as most of the content are included in the PDF file here. And the two naive Bayes model that we are going to talk about today are multinomial naive Bayes and Gaussian naive Bayes. And the main question that we will be discussing today is, when do we use naive Bayes to approximate a data, or to like predict an outcome for a given a data set, or when should we use the logistic regression? So for naive Bayes, we will use naive Bayes when all of the features are almost all independent, because it matches the big assumptions of naive Bayes. And naive Bayes also work really good with small data sets, and it also works better specifically for Gaussian naive Bayes model when the data of the features are normally distributed. For logistic regression doesn't have much assumption, but then it makes this one small assumption that there's a linear relationship between the features and the target that we are trying to approximate. So therefore, a data that is in a linear relationship with the target, with the features in a linear relationship with the target, will provide the most accuracy. And also, logistic regression works really well on large data sets, as they need a large data set to train the regression coefficient such that it maximizes the likelihood of the data. And as stated in a research by Professor Nguyen and Jordan, that logistic regression model perform really well when the training data size reaches infinity. So what we are going to do in this video is to test and examine how different kind of models, so the three models that we're using here are multinomial naive Bayes, Gaussian naive Bayes, and logistic regression, and how they will perform on the data set of diabetes that we collected from Kaggle, and then we will explain why they have different percentage. So this is like a simple GUI that we have. So basically we will like put in all of like the data in here of the input, and that will give out a prediction of whether a person is diabetic or not based on the input we have. And the model, like the thing that we are seeing here, is that it is implemented using the Gaussian naive Bayes. However, I also implemented using the multinomial naive Bayes as well as the Gaussian naive Bayes, and then I have the accuracy of it derived from all of it. So this is for the um, multinomial naive Bayes, and we have the accuracy of 66%. For Gaussian, we have the accuracy of 76%, which is approximately 77%. And for logistic regression, we have 75%. So from that, we have to ask why why is there like a difference in terms of the accuracy? And in our explanation, we will talk mostly about the Gaussian naive Bayes and the logistic regression, because it is intuitive, because the multinomial naive Bayes is like similar to like the model that we see in class. It only works best for like binary features and discrete features. So we can understand why it doesn't work really well with this data set, as this data set is continuous. However, for Gaussian and logistic regression, it can work well with continuous data. So we will talk about like why the Gaussian naive Bayes compared with the logistic regression in this case works a little bit better at 77% accuracy compared to 75% accuracy. First of all is that the correlation between the features are relatively low. As we look into this correlation matrix, we can see that the relationship between like the features of one another are not so high, as indicated by the image here, that the correlation is not so high, which means that the features are relatively independent of one another, which matches the assumption that the naive Bayes made, which is why it makes the Gaussian naive Bayes perform a little bit better. And also from this matrix here, we can see that there's a non-linear relationship between the features and the target. So this is the outcome that we have here, and we can see that most of the features are not heavily correlated with the outcome that we are having here, which suggests that it is not in a linear relationship with the target. And this kind of like disrupt the assumption that the linear regression make, which is why the logistic regression doesn't work so well in this case. And third reason is that the effect of the CLT on the mean. So as stated in the part above, that the Gaussian naive Bayes work really well with features that are normally distributed. From this, we can see that okay, not all of the features are normally distributed, which is why the accuracy is not so high. Only some are look like they are normally distributed, and the order are not. However, with a big data set, the TLT will have the impact on the mean, which like make the mean to become normal, which can somewhat alleviate the effect of scale distributions. So from this data, we can have some suggestions on like which model we could use in the future, and the factors that we should take into consideration is that we should look at the training data size, the relationship between the features and the target, and the relationship of the features among one another. So that's the end of my project. Thank you.